environmental prediction system, with again much more innovation coming related to the ocean that allows us to bring our uncertainties and quality of our forecasts to yet a different level. With it, we strive to provide Canadians and Canada the best weather and environmental forecast, which is not easy, given that every day, every month, every year we face new challenges, and bringing the uncertainty down through the type of work that you're doing here is quite important. Just like to mention a few elements in terms of the fact that we have really assumed up until now that the ocean is changing slower than the other part of the Earth system. But certainly in the last few years, we have seen elements that are challenging those views. And given the number of specialists that we have in the room today, I'm quite looking forward to the advances and understanding that you can make on those changes and how the impact that they have in our understanding of the future and how we can model it. Over the past decade, I think I've identified quite a few changes that our international collaboration, including this one, have brought in terms of innovation and benefit for Canada. There has been opportunities here in this particular group to exchange knowledge and experience, to have conversations that led to exchanging data between our different centers that are allowing us to develop the type of analysis and use it operationally on a day-to-day basis that we have through the CRIS community. Every participant to those discussions benefit from the exchanges and the knowledge that comes from it. And I'm certainly looking forward to how much further and stronger the collaboration and the connection will be done from the meeting that we're having this week. So I certainly hope that you enjoy your stay in Montreal and that you have very active and discussions that continue to advance the knowledge that we have, and I wish you a very good symposium.
Next, we have Jean-Pierre Blanchet here from the ESCCR Center for Regional Climate Modeling.
Morning. Dear colleague, it's a real pleasure to hold the 25th International SST User Symposium here at UQAM in Montreal, in Canada. And as Véronique just mentioned, we are surrounded with 3 big oceans, but on top of that, we have huge bays like Hudson Bay, right close to Quebec, and Baffin Bay in the north, and huge area at the Great Lakes, and the wide St. Lawrence Gulf with salty water. And we see whales up to 8 shark species in our river. So it is a very substantial environment. Furthermore, the 8 million square kilometer of the Laurentian Shield age up to 4.2 billion years as thousands of lakes. And to say the least, we are very much concerned by water temperature under climate change. Truly, this is an amazing land and water region. The ESCCR Center, whose vocation is to train students and also do research as an university environment, is a research center for climate study and simulation at the regional scale. We depend on your critical SST work to study storm activities, extreme weather and climate change, all the way to application for in insurance industry and decision makers. At the core of our group, we have been, put here a slide that gives you a little bit of a roadmap what we're doing. We've been developing in the early 90s one of the first nested regional climate model in collaboration with Environment and Climate Change Canada. It's the Canadian Regional Climate Model, the RCM, currently in the 6th version and used by Uranos, a consortium for climate impact assessment, and also the group called RISC is a large intersectorial network on flooding. Also on the right-hand side, you have ARIME, is a program for risk identification and evaluation for strategic hydroelectricity and mining infrastructure in Quebec. Another key research sector is the boreal forest under climate stress with intensive fire events and modeling of the forest carbon cycle. ESCER is also actively involved in the IPCC assessment report and CORDEX, the International Coordination Regional Climate Downscaling Experiment, among others. An ongoing effort, SACHER, represented here in the middle, is dedicated to developing a very high resolution climate model at kilometer scale for better resolving topography, rivers, urban environment, and for the new generation of regional climate model. In parallel to model simulation, the ESCER team, my group in particular, has been developing for 15 years an innovative spectroradiometer called TICFIRE for Thin Ice Cloud in Far Infrared experiment. It's extending the measurements, satellite measurements into yet unexplored far infrared range for improving cloud and also process at the kilometer scale, same scale as the model. But recently we had PREFIRE. My colleague in the States has launched the PREFIRE is a precursor to what we will do in the future. Our instrument is part of the Canadian HAWK mission on NASA Atmosphere Observing System, AOS, and it's due to launch in 2031. For us, it is within this context that highly reliable SST data that you are providing are key information on both satellite observation and climate simulations. Thus, it's with great enthusiasm that we welcome the GHRSST and meeting of the SST User Symposium. I wish you a very successful meeting and bienvenue à Montréal. Thank you.
Thank you, Jean-Pierre. Next, we have the pleasure to have Isabelle Marcotte with us today, the Vice Dean of Sciences here at UQAM.
Bonjour tout le monde. Good morning, everyone. It's an honor for me to be here today to speak on behalf of the Vice President of Research of the university who couldn't make it this morning. I'm happy to be at this 25th International SST User Symposium and GHRSST Science Team meeting. First, I would like to thank our host, Environment and Climate Change Canada, and my colleagues at the ESCER Center for organizing this exceptional event. For more than 50 years, UQAM has been committed to educating students and citizens ready to transform society. With over 35,000 students and more than 300,000 graduates, our university is a beacon of knowledge and innovation. We are proud of our 7 faculties and schools and our nearly 120 research units, our 30 Canada research chairs, as well as 5 UNESCO chairs, all of which illustrate our commitment to cutting-edge research. The Faculty of Science at UQAM, located here in the Pierre Dansereau Science Complex, is a true gem in the heart of downtown Montreal. Equipped with state-of-the-art infrastructure and specialized equipment, it brings together over 300 eminent scientists. Our researchers, connected to contemporary scientific issues, have distinguished themselves nationally and internationally, winning numerous prestigious awards. Research in earth and environmental sciences is particularly particularly strong in the Faculty of Science. This field spans 7 fundamental themes, including the study of global scale changes, oceans, earth dynamics, climate modeling, forest ecosystem dynamics, the structure and functioning of lakes and streams, the management of animal species, from the conservation of endangered species to the management of nuisance species, the fate of contaminants in the environment, and the sustainability of agricultural practices. The Institute of Environmental Sciences is one of our flagship research units. With its 4 environmental training programs across 3 academic cycles, over 1,900 students have graduated with a master's or doctoral degree in environmental sciences since the inception of these programs. These qualified graduates contribute to Quebec's next generation and forge connections worldwide. Their scientific contributions and their involvement in their field of specialization and with communities contribute to the recognition of environmental sciences as practiced at UQAM. The international appeal of the Institute's environmental science program testifies to the relevance and interest of this form of higher education. The ESCCR Center, the only French-speaking meteorology and climate training center in Canada, works on the study and simulation of climate at the regional scale. Its members are interested in several research areas, including numerical simulation of the atmosphere and climate at the regional scale, hydrological cycle modeling, and the study of climate change and its impacts at the regional scale. Through its cutting-edge research, the ESCCR Center helps to better understand the climate system and its transformations. We are proud to count among us these researchers who significantly contribute to the advancement of knowledge and to the renown of our institution. As Jean-Pierre mentioned earlier, the ESCCR Center recently secured new funding to support the development of the thick-fire nuagic instrument, a project initiated in 2006 by Professor Jean-Pierre Blanchet of the Department of Earth and Atmospheric Sciences and director of the ESCCR Center, in collaboration with the Canadian Space Agency. For this project, he received nearly 8 million from the Canada Foundation for Innovation under the ARC Avenir project conducted jointly with the University of Saskatchewan. This federal support, in addition to provincial funds, will strengthen research and innovation capacities in the field of earth and environmental sciences. Our collaborations, such as the thick-fire mission and the ARC-SAT project with the Canadian Space Agency and the NASA, demonstrate the importance of synergy between academic research and space agencies for scientific progress. UQAM also works closely with the URANOS and Environment and Climate Change Canada to develop partnerships, contracts, and training that address current environmental and climate challenges. These initiatives are crucial for the Faculty of Science, as well as for other faculties such as geography, political science, and economics, all of which contribute to a holistic understanding of climate change. In addition to our research and training efforts, we are committed to broadly disseminating scientific knowledge. Our researchers actively participate in conferences, publish in high-level scientific journals, and collaborate with worldwide renowned institutions. This international visibility enhances our ability to attract talent and forge strategic partnerships essential for addressing global climate challenges. In conclusion, I want to emphasize the importance of this symposium for the global scientific community. The discussions and exchanges that will take place here this week will play a key role in advancing our knowledge and strategies to address climate challenges. Thank you all for your commitment and passion. Together, we can continue to push the boundaries of science for a sustainable future. I wish you a fruitful and inspiring symposium. Thank you.
Merci beaucoup. And last but not least, our final welcome from Anne O'Carroll, the GRIS Science Chair, who I believe you all know.
Hey, good morning, everybody. My name is Anna Carroll. I work at EUMETSAT. I'm the GHRSST Science Team Chair. Thank you very much for all the warm welcomes this morning. It's an absolute pleasure to be here, and thank you to our hosts. It's really wonderful to be here in Montreal this week. So I'm going to give you a few short slides just to describe the Group for High Resolution Sea Surface Temperature and what our main objectives are. GHRSST has been around for over 20 years now. This is our 25th meeting. So it first of all grew out of the needs for operational weather forecasting and operational oceanography, particularly from the needs of the Global Ocean Data Assimilation Experiment, GODI. But over the years, it's expanded all the user needs for any applications needing sea surface temperature from the satellite constellation, and of course, including climate purposes as well. So our mission statement is to provide operational users in the science community with the SST measured by the satellite constellation. It provides a framework for SST knowledge and data. We have best practices for processing and uncertainties, and it brings SST to the operational users in science. So it's an open international science team. People interested in sea surface temperature are welcome to join at any time, and all the meetings are open. So this is just a description of how the science team works. So we have a core science team. This is supported by the GHRSST Project Office. So this is Erica and Pia run it at DMI. It's funded by Copernicus, managed by EUMETSAT. So that has then links to the CEOS teams, the SST virtual constellation and the wider CEOS teams. And we also have an advisory council supporting those activities. Within that, we have various technical advisory groups focusing on specific areas. And from those, we also have specific task teams that can work on any kind of issue or problem, such as cloud screening, high latitudes, coastal SST, uncertainties, amongst others. So who is involved? Well, there's many stakeholders and patrons and sponsors to the GHRSST science team, and it's increasing all the time. We're always open to new participation and members. So why is sea surface temperature important? So it's important for atmospheric circulation, circulation of oceans, ocean biogeochemistry, and of course climate change. And this, of course, in the last few years where we've seen such extreme temperature increases, marine heat waves is becoming much more important that we continue to monitor these from satellite sea surface temperatures. Over the last couple of years, we've had a real focus on marine heat waves. At the GHRSST Science Team meeting last year, we had a session dedicated to this topic. You can find the information online. They're becoming much more frequent and the intensity is increasing. And the continued importance of this is something we need to continue to look at. I've already mentioned the global SST anomalies is really increasing a lot in the last few years. So this is something that is really now a big focus for our team, in addition to the original kind of operational weather forecasting and operational oceanography aspects. We're also looking much more at high latitudes, looking at sea ice extents and how this interacts with the sea surface temperatures at high latitudes. We're also beginning to look at sea ice surface temperatures in the high latitudes and looking at the marginal ice zones and the consistency of surface temperatures in these regions. So what are our next priorities? So we wrote a white paper a few years ago, which gathered really a lot of our user needs. There's a lot of information in that paper, but coming really for the main issues coming out of that paper were to improve the data quality in the Arctic, improving coastal SST data quality, and improving SST feature resolution. So a lot has been done already in the last few years, really focusing on these aspects, from retrievals to cloud screening, to new data products, to consistency of these surface temperatures in these regions. For coastal SST, we have a number of very high resolution new satellite missions coming up. So how to really exploit and provide products from these new satellites will be an important thing to do over the next few years. And improving SST feature resolution. So this includes aspects such as improving the way that AI is used for sea surface temperature products. So a lot is ongoing, and yeah, we'll continue. So the GRIS Project Office. So the GRIS Project Office coordinator is Erica, who you've all met, and Pierre is the GRIS Office scientist. The GRIS Project Office is the team is run at DMI, so Joanna's here as well. Jakob's online, I think, and it's funded by the European Union's Copernicus programme. So welcome to everybody to the meeting. And thank you again to our hosts for co-hosting the symposium in Montreal, and particularly thanks to Dorina and Sergey and Melanie for all your organisation and support to make everything go smoothly. We're very happy to be here. And we also have a fully virtual meeting, and thank you to the GPO team and also the EUMETSAT team for all the online meeting organisation.